Hello and welcome to Presents. I'm your host, Sky McGeehee. This week we are joined by Dr. Flores, who is the director of the Lab for Ecohydrology Applications and Forecasting, or LEAF for short. Dr. Flores is also an associate professor in the Department of Geosciences. Please join me in welcoming Dr. Flores. It's a pleasure to have you on.
Thanks for having me, Sky. I'm glad to be here.
So why did you choose to get involved in geosciences?
It sort of runs in the family. My dad's actually a geoscientist, and as we were talking about just before the camera started, I grew up in Colorado. Grew up seeing mountains and rivers and forests, and so I've always just had an appreciation for the earth and for the places that we live, and so it was sort of a natural fit for me.
So what do you appreciate most about Idaho's climate on that same?
Yeah, so the thing that I love the most about Idaho's climate and the western U.S. in general is just the variability, the natural variability we have. We have, cold and snowy winters. We have beautiful sunny springs. We have hot and dry summers, and that's something that I've just grew up around and I really appreciate about Idaho.
Probably similar to Colorado. It's nice to be somewhat near home.
Yep.
So I know there's some confusion about this, but in your own words, how do you define the difference between hard science and soft science? Yeah,
so that's a great question, and I think that on some level there's maybe some perception gaps between there. In the sciences, increasingly we're not using sort of the terminology of sort of hard and fast science. The way that we look at things is that the pursuit of science is really just the application of kind of specific ways of approaching problems, right? So we view the scientific method or the way of doing science as just an application of a set of techniques and ways that we look at problems and try to better understand how things are happening. And those sets of techniques are actually applicable whether you're studying, quarks and tiny subatomic particles all the way up through, social systems and how cultures evolve. And so increasingly that distinction is sort of one that is sort of fading away, and it's really, we're more applying sort of scientific perspectives to a range of different problems.
Okay, so what's the difference between the historic climate cycles that we've seen, like the Ice Age, and what we are seeing today?
Yeah, so historically the things that drove large variabilities in climate had to do with things like the orbital cycles of the Earth, right? And some very large perturbations, things like asteroids that would hit the Earth, things like large volcanic eruptions or large geologic events. But those typically took anywhere between hundreds up to millions of years to sort of lead to large-scale changes in climate. What we're seeing over the past 200 years is just as we have industrialized as a planet, as we have moved towards the use of carbon-based fuels to power our industries, transportation, electricity, agriculture, we've seen this dramatic increase in carbon dioxide, especially in the atmosphere. And carbon dioxide is a gas that is really important because it traps radiation that's going out from the Earth in the atmosphere, warming the atmosphere. And so what we're seeing now is just hallmarks of the human footprint, the human fingerprint on our climate. And what we're seeing is changes that are very dramatic in terms of their speed, right? So geologically speaking, fast is something that happens in say a few hundreds of years, right. And we're seeing changes on the order of decades, and that is a blink of an eye in geologic time.
Extremely quick,
yeah.
Right. So in that same vein, do natural hazards pose more of a threat to society than man-made ones? Like, for instance, is it more likely that some river somewhere in the U.S. floods beyond its 100-year floodplain, or that a river floods due to a dam breaking in California due to an earthquake? Yeah,
so that's a really interesting question, and I think that the really fascinating thing to think about is that the term hazard actually, when we use the term hazard, we almost always mean that in the context of hazards to human health, the property, human life, human
Structure,
well-being.
right.
And so what's fascinating to think about that is that there's almost no such thing as a hazard in the absence of humans. And so both of those, what you sort of mentioned, are sort of hazards, right? If there were no Boise along the banks of the Boise River, on some level, if there were no people, no humans inhabiting the Treasure Valley, the flooding that occurs isn't really sort of a hazard per se.
Right.
And so, we think about a lot of those things in my field in hydrology about, the probability that something will occur, and how frequently that sort of reoccurs, and then the associated impacts of that. The thing that climate change does that sort of primes the pump, for instance, in doing is in changing the magnitude and changing how often those things are, how frequently they occur, and making it to where, for instance, the 100-year floodplain changes because the frequency with which we see these events is sort of changing. So to use a really good example, for instance, there's a scientist at the University of Georgia named Marshall Shepard, who's an amazing scientist. I admire him tremendously. And he has this really great analogy of what climate change does to these systems, right? So if you look at the steroid era in baseball, right, which Boise State is having its first baseball game in 40 years today, the steroid era, what we saw is just this dramatic increase in the average number of home runs hit over year, right? It's impossible to say, which of any one of some players' home runs was caused by steroids, but we know that the net effect was an increase in the number of home runs, right? So it's tough to say, for instance, which individual events might have been worsened by climate change or were caused by climate change, but we know, for instance, that the patterns of events are getting sort of more extreme, more frequent, and more intense through time.
Okay, that makes sense. Can you kind of explain to me what like the 100-year floodplain means? Just because I'm kind of confused about
that. So what a 100-year flood means in general is that it's a flood that on average, and that's kind of a key phrase, on average happens once every no more than once every 100 years, right? Okay. And so we think of that as a flood that on average would happen no more than 1% of the time in any given year. So you can actually get, 2 100-year floods year to year. It's just that was improbable, but not impossible. But as I mentioned with that analogy, right, is that that's almost always looking backwards, right, over what happened in the past 100 years. So as we know that climate change changes things like temperatures and precipitation and snow versus rain patterns, those patterns, those statistics will change over the next 100 years. Okay, yeah, it just seems like almost like a dramatic term to me that it doesn't actually seem to mean such as such a drastic thing. Yep. So why do only 97% of scientists agree about climate change? So this is a really interesting question, and the way that I might phrase that, my response, right, is that 97% is actually sort of nearly unanimous, right? If you had 10 friends on Friday night trying to decide whether or not to go get burgers or pizza, right? If 9 of them want to go get pizza and 7/10 of the other person is like potentially into pizza, you're going to get pizza, right? And so, the studies, and a number of studies sort of periodically do this, where they will go and survey the climate science literature and just sort of categorize them into those papers, those studies that support the idea of anthropogenic or human-caused climate change, and those studies that go against that. Okay. Depending on how you look at that, some studies suggest that the number is even higher, closer to 99 or 99.5%. So And what's interesting about this, and what I would tell the audience is that if you're really curious about this, there's a great website called skepticalscience.com, which looks through kind of all of the various confusing aspects of climate and climate change, and goes through and provides real evidence as to which claims have merit and which are kind of fabrications. But what we know is that over time, the scientific consensus has been getting stronger,
right,
that climate change is real, it's happening now, it's caused by us, and that it's going to have really, profound ramifications no matter where you look in the world. Those ramifications might be different, but all of the world will experience effects of climate change.
Okay, so it's more just the disagreement on what's causing climate change than...
It's not even a disagreement on what's causing climate change. That 97% or 98%, it's generally agreed upon that, that humans are causing climate change. Where there is uncertainty, for instance, is in very nuanced things, for instance, like, where will the sort of rain-snow transition elevation in the Boise Front Mountains be 50 years from now, right? There's uncertainty with respect to that, whether it'll be, 100 feet plus or minus, some projection. But nearly unanimously, climate scientists and people who study climate are in agreement that climate change is human-caused.
Okay, so on a different scale, I guess, why do you think the average person would deny the impact of humanity on, deny the impact on the environment of humanity expanding?
Yeah, so I think that part of that is truthfully sort of the way it's framed, particularly sort of in the in mainstream media outlets, for instance, right? So when I look at the way that climate change is covered as a topic in many venues, for instance, there will be a climate expert, and then somebody who challenges the consensus on climate change, and they're sort of given equal time and equal footing. And I think that although I understand what the interviewer, the show is trying to do, right? Why they're doing that. What that conveys to many in the public is this idea that the argument for human-caused climate change and the argument against human-caused climate change are on sort of equal footing, right? And so when people are seeing that, I think they're frequently, it's confusing. It makes it appear as if there is not this sort of large consensus, right? Whereas if you took that, in a 100-minute interview segment, for instance, if you took the scientific consensus, you'd devote 97 minutes to the perspective that humans are causing climate change and only devote like 3 minutes to the opposite perspective. So I think some of it has to do with the way that it's framed in a lot of, I think truthfully, a lot of sort of mainstream publications and TV shows just haven't figured out how to cover a subject like this. So, although I think it's improving. It's such
a complicated topic, though, that it's hard for layman terms to really work out in that. So speaking of that, with the recent rise of climate activists becoming more like celebrities, I have to ask, how much of their claims do you think are kind of exaggerated?
It's tough to know. I think that what is true is that it's easy for certain claims, right? For instance, to get ginned up in the press, or certain phrases to be sort of cut out of what some people say, and ultimately sort of made into an issue that gets a lot of retweets on Twitter, gets a lot of noise generated in Facebook. But I think that it's one of those issues where it's great that we have kind of web pages like Skeptical Science. It's great that we have scientists like myself increasingly sort of trying to train our students better to communicate to audiences like this directly, so that we don't sort of necessarily need kind of celebrity intercessors to kind of to have that conversation. So what I'm really excited about is just this idea that we have, you know, a new generation of scientists, a new generation of communication scholars that are actually able to sort of bring that discussion directly to the audience and not rely on sort of some celebrity intermediary or somebody to sort of boost that signal.
So Representative Alexandria OcasioCortez, I believe is how you pronounce it, said that the world is going to end in 12 years if we don't address climate change. So do you consider these extreme, almost apocalyptic claims that are like this to be harmful or helpful in the overall climate change narrative?
Yeah, so that's exactly one of those sort of quips that got sort of a lot of press, right? But when you dig deeper, right, what Representative OcasioCortez was saying was that she was communicating sort of the anxiety and some of the fear that younger people that she represents sort of have, right? She was articulating the concern of her constituents, which I think is what we sort of want our Congress people to do. So while it's true that that clip alone, if that was all that was said, right, might be problematic because no, the world is not going to end in 12 years. And truthfully, we have, you know, we have. I think that what is agreed on is that we need to start acting now when it comes to sort of reducing, you know, carbon emissions. What was being expressed, I think, was a much broader kind of feeling of a lot of younger people that are just sort of like, hey, you know, this is something that we would like to see the world kind of and countries like the U.S. sort of get more serious about, and you know, and so I think that again sort of represents some of that, some of the way that sort of the climate. You know, the climate crisis is sort of framed in the media, right? So it often, you know, we pick up phrases here and there and we sort of needle at them. And so yeah, I think that often it's sort of the way that things are framed, and when you dig deeper and sort of look, you know, there's some real concerns that are being addressed there. So
do you believe that this framing actually leads us closer or farther from the truth about climate change?
Yeah, so it's really fascinating because when I look at sort of what I'm most optimistic about and sort of most pessimistic about when it comes to this debate, what I'm most excited about are conversations like this, right? Like opportunities where experts can meet with the local media, local outlets, and talk about the issues that will impact, you know, that will the climate issues that will impact that local area, and the way that it will be in ways that are different from anywhere else. I'm really excited about those things, right? And truthfully, things like social media make that easier, right? Because it's easier to find those people. I think it's more of the sort of national level and just the way that increasingly sort of eyeballs and clicks draw, you know, drive kind of the narrative that's really sort of problematic. And so that I think is that's where I think I have some heartburn, I guess, about the way that it's framed and covered. You know, but what I see, for instance, though, is that you know, it's these conversations that are starting to happen more frequently, right? Like these local interactions, people being able to go to people at their universities and in their government locally and say, you know, hey, what are the things that we should be thinking about and worrying about with respect to climate change in Idaho? So
I was reading about this earlier. Apparently there's an iceberg like the size of Florida that's about to drop into the ocean. How would that affect, say, Idaho or more inland states?
Yeah, so that's also a great question, right? At first blush, you might think, well, it's not. Right? An iceberg calving off from Antarctica, you know, and even that process happening more frequently, leading to sea level rise in places like California and Oregon and Washington or Florida, might not directly impact Idaho, right? But it has definitely indirect impacts, and those indirect impacts, for instance, are insurance companies on the coasts, which they are actually starting to do, writing in riders into policies that will prohibit covering of damages due to sea level rise, or just outright not writing policies for houses that are in kind of a zone that is likely to be impacted by sea level rise. Well, there's basically tons of articles every week talking about what an awesome place Boise is to live, and about all these people from other states, moving to Idaho, moving to Boise specifically. So things like sea level rise actually can impact Idaho because they potentially displace people. They make it more expensive to live along the coast, and people are like, well, okay, maybe this is the time to move to Boise. I've heard great things about it. And so, while it's unlikely that anybody is individually doing that kind of individual calculus, in total, right, in sum, that might be sort of the indirect impact of things like sea level rise.
Okay, so I just have one last question, and it's the one that's most interesting to me. So many people worry that poorer nations will be deprived of the cheap energy source they need to develop. In regard to how climate change would affect undeveloped nations, an MIT climate scientist Carrie Emanuel claims that if you want to minimize carbon dioxide in the atmosphere in 2070, you might want to accelerate the burning of coal in India today, saying this would basically accelerate their development, making their citizens more wealthy, more educated, and less likely to use coal as an energy source in 2070. How do you feel about this strategy?
So I actually, I got my PhD from MIT, and I know Carrie Emanuel, I know his work. He's an outstanding climate scientist. Sometimes he has, and I think, in part to sort of drive increased discussion about this, he sometimes kind of makes proposals like this just to sort of get people talking, right? So he's also been one to talk about, solar engineering as a way to, for instance, mitigate the effects of climate change. I think that what's being said there, right, is this idea that if you look historically, generally speaking, it's the more developed countries, the countries that have kind of more developed economies, more educated people, higher income, that tend to be better able to control their carbon emissions, and more able to sort of design their economies in ways that are appropriate. I think that what's needed, right, so my message is that at this point what we need to be doing is thinking about any way that we can keep that carbon, that coal, that oil in the ground is beneficial. And so I think that there really is a need for folks that are interested in international development to short circuit that pathway, right, of burning coal to develop the economy and getting to kind of this magical place where all of a sudden, you are able to deal with or able to sort of move away from fossil-based fuels.
It's not a concern as much anymore.
Exactly. So, well, I think it's really that we have to start innovating and getting creative about how we do development in places like India and China in ways that don't rely on and don't require so much coal.
Or we can make clean energy kind of affordable for those nations.
Exactly.
Well, thank you for answering that question. It was really kind of confusing to me.
For sure.
Unfortunately, that is all the time we have for today. Thank you again to Dr. Flores for coming onto the show. I'm your host, Sky McGeehee, and this has been Presents.